Hello, everybody. It's almost full house. My name is Fabien Papleux. I work within the technology innovation group at Accenture. Um, First of all, we're going to spend a couple of slides to put some context. We're going to talk about humanoid robots. And so, first of all, I think given the topics presented today, I want to make sure that you understand that this presentation is 100% human. No AI was used or otherwise harmed in the process. I'm looking at my friend Jenny there because she participated in this process, and she's like, maybe you can't say that. I want to. So I've been in the tech industry for about 30 years. Within innovation for about 25 of those. I've worked on introducing e-commerce in the enterprise back in the 90s, being a product manager for an MP3 player in early 2000s. And so it's part of my DNA to work in innovation like this. So as part of the context, I wanted to just draw the attention that sometimes I feel underwhelmed by things. And I want to mention there's really, two kinds of innovation people, and you meet them here. You get what I call the SpongeBobs, which are sort of the people who get really excited about those things, and they talk, they get you into it, and it's fun, and so on. And then you have the Squidwards of the world, and the Squidwards' role is more sort of, running the business, get their Krabby Patties out, making sure customers are happy, and those sort of things. So out of the two types of innovation people, I'm kind of more the Squidward type. So as we're starting this, I see there's a lot of people, so there must be a lot of interest in humanoid robots. And I am sorry to say they're not there. But there's also a good side, and hopefully the presentation is going to take you through a number of things that we looked at and the areas that are paving the way for them. So as part of context and talking about innovation, I wanted to just quickly start with how we measure, innovation and where we are in the process of developing, those new technologies. And in that process, we often use Gartner's hype cycle because Gartner usually, identifies very early, the new technology, the new terms, the new models, and they help us understand, the difference in expectations from people, from the beginning to, the point where they start really delivering value. As in my Squidward role, I would say, if your expectations are anywhere in the gray zone, right, you're in a are you nuts zone, right? Because Gartner, usually when, they bring it up in the expectation, it's really the top you can be. I usually look at never getting into the actual purple zone, because it's where you burn your tips, the tips of your wings, right? Very often, if you follow the whole cycle, it gets, really, really hyped. Everybody's interested, we're investing money and so on, but it has to come down, right? And if 90% of startups, fail, it's often because of things like that. So I like to moderate expectations, while it's going up. And on the other hand, when it comes back up afterwards, I tend to look at and have higher expectations than, what Gartner looks at. I expect growth, I expect long-term value, and I'm expecting, everybody to raise the bar because, that's where the opportunities really are. So now, we defined humanoid robots. So also for context, at some point we got an email from our group CEO of technology who said, hey, what's our point of view on humanoid robots, right? Because at some point Elon Musk introduced Optimus. And so journalists started asking questions. And we thought, what an odd thing to do. Why should we have a point of view on this? Because none of them are in the market today. So we started by defining exactly what it is, which to us is a robotic system that mirrors physical and functional traits of humans. And we specifically didn't include teleoperations for robots, as well as other types like exoskeletons and to some degree vehicles, which as they're becoming more and more intelligent and are serving humans, are sort of becoming extensions of us. And so the first thing that we started looking at is history, because we wanted to understand why. We want to understand why are we thinking about building very expensive machinery that look like us when we know that for very specific functions, we are not, the best model. We're the more adaptable model. We're good at a lot of different things, but we're not extremely good at individual things. Right? That's why our robots today are designed the way they are, because they're very good at the one thing that they do. And so I wanted to go back in history and try to understand, where does that come from? Is it really that ingrained in us? And it seems the answer is yes. All the way back thousands of years ago, in mythology, you have traces and stories about creatures, about automated, I wouldn't say machines, but automated human-looking, personas bidding, doing the bidding of humans. That's the case, for instance, of just take Daedalus, whose son burned his wings by flying, too close to the sun. There are tons and tons of these examples. And then, we thought, well, how can is it possible that this difference in how robots are adopted across the world also be explained by the same phenomena? And we could write books and books over this. As soon as we started researching, we found so many things that we thought, that would be like classes forever, just on the topic. You have to know that about 75% of the market in robotics is shared between Japan, Korea, and China. About 12% in Europe and another 12% in North America. So the discrepancy is huge. So why, right? And you see that a lot of the stories happening within, Western mythology actually become at some point a bad relationship between humans and those machines. They get out of control. We try to control them, and they get out of control. On the other hand, in Eastern culture, and Shintoism is a good example of that, we found that image is often attributed to ancestors and spirits who are there to protect, and they protect the forest and they protect the seas. But they're not, sort of the king of the sea. They're protectors. And so the story flows in a very different way. And so very ingrained in our culture is this thing that we see today, thousands of years later, where our adoption of robots, if you ask people, are they afraid of robots? The answer is going to be overwhelmingly yes in Western culture and no in Eastern culture. It's really, really flabbergasting. So the first trace of an actual human-shaped object, mechanical object, we found it dating back to 4000 BC in ancient Egypt. So that's also how far this goes. And then, of course, throughout history, it continued to grow. It's part of our popular culture. It's part of a ton of things that we're part of, and it continues today. Today, we have a lot more capabilities, and we building robots for factories. We're starting to build robots for other purposes, and we've started to see human-shaped robots, whether it's the Boston Dynamics Atlas, and there's a range of others that we looked at. And of course, here I use Optimus as the example, not because of the robot itself, but really because the point that Elon Musk is trying to make through this, having a robot that looks like a human, that weighs about 75 kilos and would sell for $20,000 is basically a consumer product, right? His point is he's looking at a robot in every household, right? A little bit like we invented the PC back in early 80s. And you would buy that like you would buy a car. So the market for this, the market is actually really small right now. We interviewed a number of CEOs. The CEO of Engineered Arts, for instance, evaluated the market based on his experience at about $10 million, which is tiny, right? But we're seeing also a growth of about 33% a year. So we know there's money pouring into it, and that a lot of development should be expected in the next 10 years. Now, in terms of function, there's really 4 use cases that are worth interest at this point. I'm sure there's going to be more. We haven't looked at the consumer aspects for a number of reasons. But in terms of business, there are really 4 use cases. The first one is the service worker, whether it's in retail or other service functions. Robots are becoming more and more used, and this is a good use for this kind of robots. The agile industrial laborer is basically there for use cases where the specialized robot would have a harder time executing the task. Because, for instance, our world is not necessarily engineered for robots today, right? A robot on wheel is going to have a problem walking upstairs, right? And we have stairs everywhere. We have doors everywhere, and that requires manipulation. And so having this kind of robot in place actually allows the automation to find its way into logistics, find its way into manufacturing in between lines to provide automation service. The tireless giver is another really interesting case, because more and more we need nurses, we need people who care for the elderly, right? It's very much part of the silver economy, and there's a good case to use robotics to help with a number of use cases there. The scalable entertainer is about using robots in museums or other venues for using someone for direction, for, telling stories, and, doing things like I do right now, just presenting stuff, right? So those are really the 4 use cases. Humanoid robots, right? We started then breaking down what it means and what they should be able to do, right? It's about moving. So it's a robot on legs. It needs to move like us. So it needs to evolve in the same environment as we do. It's about communication. It's about being able to interact with humans. It's about thinking like humans, having the cognitive abilities that humans have, looking like a human, because it's always easier to interact with someone who looks like you. And also manipulation. Manipulation is going to play a really, really big role. But as I mentioned earlier, manipulation in and of itself is a huge field in robotics. You have people still studying, how to pick up strawberries, because there's no such thing as a robotic version of a human muscle, right? And so we're using all kinds of different techniques to do manipulation. But a hand for a humanoid robot today costs about $50,000. And you need 2 of them. So there's $100,000 worth of equipment right there. So it better do, everything that it needs to do. It should be able to open doors, open a bottle, do everything that, another human would do, which is going to raise the price even more. But it's still an interesting area to look at, because there is a real convergence in terms of technology that brings this together. When you look at artificial intelligence, we are now able, and we have a team at Accenture working on inspection and monitoring, for instance, based on robotics. And so we have a good grip on how you go around, right? Plan paths and movements around spaces. And you heard about public spaces, I think earlier from Maria. And artificial intelligence is really part of every aspect of this. And the growth in artificial intelligence is enabling robotics. Cloud is fundamental in how we use robot, because a lot of the capabilities need to be offloaded from the robot. Boston Dynamics Atlas, right? Your robot that flips over and those sort of things, really runs for like 15 minutes today. Mm-hmm. So every time you can take a process and offload it, to another platform, is time that you gain from the batteries. Material science, right? Making robots lighter, stronger. All of this is really part of, how this is all converging. The rise in computing power is part of it. And obviously the ability in cognition and the cost of hardware also, continues to go down. But as I usually say, it's not because your imagination can go there that you necessarily should. Someone is preparing something about Jurassic Park, but it's related. Mm-hmm. So there's a number of non-technical aspects also that needs to be looked at. And the ethics part in unintended consequences are things that we haven't really evaluated or that we have a really good grip on yet. The fact that humans can create emotional attachment to these robots is something that we haven't completely grasped, but it exists. And when a person needs to choose between supporting a human and supporting their robot, it becomes an ethical question. Persuasion power. It's amazing because a couple of months ago, the United Nations invited a number of those manufacturers, people that we talked to bring their robot to the UN in New York and have a press conference. And you had all these robots around the table and journalists in the middle, and the journalists actually asked questions to the robots. And there were questions about, do you think you need more regulation for robotics and artificial intelligence? And robots would answer, yes, we think there needs to be, regulations for this and that. That's public manipulation, right? The robot doesn't think that. The robot doesn't think. It says what the people behind, want to say. And so 1 or 2 days later, the UN announced that they were creating a new committee that was looking at regulations of artificial intelligence. And of course, public opinion had been molded, right, by the fact that robots answered questions from journalists, which is a huge question, really. And of course, there's a number of additional things that I'm not going to drain here, but social stratification for me is also a very big thing. It doesn't only happen in robotics; it happens everywhere in our lives today. There are more and more classes of haves and have-nots, and access to that technology, right, determines your opportunity for success in the future. And so that becomes also a very big question that we need to address at some point, which is in part why in my next project, we're going to start looking at responsible architecture. And hopefully I'll come next year to discuss that. But we need to translate all of these things in actual systems and talk to people about how you do this, how you make sure that everyone has access. So, real problems today that are in front of people like us and you thinking about developing those robots. Those are the technical barriers, the power to weight ratio. It's funny, but you need big batteries, big machines, really strong joints, and those sort of things. They become very heavy. And the balance of how much power you need to move this, right, is not quite there. If Atlas has 15 minutes of battery power to do what Atlas needs to do, then we're in front of a problem. Because you cannot just add, more batteries, because obviously batteries are a huge weight. Computing power, right? The more we move towards, intelligence, the more we're going to have to execute inference calls, for AI, and the more we're going to need computing power, and that needs to be onboarded, which creates a drain on power, which creates heat, and at the end makes it, not always very applicable. So again, I'm not completely going to. Wrong keyboard. So the timeline. Not everything is dark. I mean, either you're asleep or you're thinking, oh my God, I thought it was going to be exciting. But the reality is, they're coming. There's no doubt that they're coming, right? The question is when. And from now until that time, what needs to be done? What can we do today to move in that direction? And so we think that in the next 5 years, there's a lot of enablement work that can be done, right? It's sort of foundational work that we're doing for all of robotics in general, but that will be essential for humanoid robots to have an environment to evolve in. In the next part, we're going to see commercial products. Boston Dynamics Atlas, according to Boston Dynamics, is about 5 years away from being commercially available. There are other robots that are maybe even a little closer, though their application use case may be a little more narrow. So they're coming, they're going to be there. We think that it's going to take probably about 10 years to have mainstream products, right? To have actually to see some adoption. If you remember the slide with the growth in market size, you could see that about the 10-year mark, there seems to be that inflection point, and we could be in that direction. But really, that kind of robot becomes useful and really interesting when it turns into a general purpose robot, right? There's no point in having $100,000 worth of hands if the work you're going to do is rocket science, but the dishes, yes. However, if you build a robot like this, then it needs to be able to do both. And then it becomes, it becomes useful. It becomes something that you will see in houses, you will see in businesses. But general purpose AI is far off, for a robot that, will walk into the street. So we think that bringing it all together is probably 40, 50 years away. But there's a ton of things to do in the meantime. My suggestion, and it's just my suggestion, my team's suggestion, is to look at, over these next 40 years, there's a bunch of things to do, right? Right now, there's major improvements in AI. Right, so it is worth investing your time in this. AI is going to be essential, right? When you look over, 10 years later, right, there is going to be a whole road to general purpose AI. It's already sort of happening, and it might actually get there faster. We don't know. Sometimes, technology really just advances faster than we expect. I don't have a crystal ball. But realistically, there's still a ton of things to do. So more in the mechanical space, right? There's a ton of mechanical improvements that are needed in manipulation, in materials, in the availability of those things. And then there's a huge barrier in terms of battery and power management, right? We need better ways to store power and to use more power. I know, we're all looking at sustainability and figuring out how we can use less electricity and power, but really the history of, humankind does not go in that direction. We are going into the direction of using more power. So we're also going to have to do it, in a responsible way. There is a security and computing revolution. If you have been able to attend any talks around quantum computing, in generally next generation computing, as it comes through, this has a power potential also to completely change the game in terms of how we process that information, but also how we secure that information. And then there's a level of that is non-technical. Right? Responsible technology is something real that we need to address because our systems are more and more complex. They become very widely distributed. And because they're very widely distributed, it's very hard to have a holistic view of an architecture these days. Right? I have an example that I walk around of a fuck up by, Amazon, but where I made a purchase on Amazon. That purchase was from a third-party vendor selling on Amazon. My package was sent through the post, which then went to a distribution center and an individual contractor that was distributing the package. All of this, right, using part of the post systems and Amazon systems and so on. The result is I opened my app on Amazon and it said, attempted to deliver package at 10:41. And I looked at my phone, it's 10:02. right? This is a real problem. It's a huge problem. If you can solve it tomorrow, we're going to be in a much better world. And then, of course, past responsible technology, we're talking about ethical technology. It's sort of the next barrier where, beyond just being responsible, it needs to work for us. And then all the way through, we need to make our environments robot friendly. A robot needs to be able to open the door. As long as there's a handle on the door, we're going to make it very expensive for the robot to open the door, right? We need to automate doors. We need to automate elevators. We need to have ways, to walk up the stairs that are less expensive. We need to do all of these things, right, for robots to be able to live among us. And that's a very long road. There's a ton of things to do there. And that basically is it. I'm done. Not yet.
So let's start. Wide use of full automation is artificially slowed due to keep enough job for certain.
I'm sorry. I lost the question.
Wide use of full automation is artificially slowed due to keep enough job for certain groups of people. Is it also impacting research, development of robotics in some way, or we are not there yet?
That's a really good question. There's no doubt that there is a very clear response from companies when we talk about automation and adoption of robotics to protect jobs, whether they're unions or workers' representation and those sort of things. We think, like any technology revolution, it's actually going to create a lot of jobs. Now, of course, those new jobs will probably require different skills. And so that means that, we will have to take time to adjust to it. But it's a trend that is true across technology, and it's no different for robotics. But in the end, this actually creates, more interesting work than we have today. It doesn't really stop research. Actually, there's a lot of work that we also do to use robots to accompany people rather than replacing them. Because at the end of the day, if you take an Amazon warehouse, for instance, yes, the back of the warehouse is automated by robots where, the speed of going to get things on the shelves is important. But then the sorting of the bins is something that humans are much better at than robots. And so you still have people who are standing in front of the warehouse to prepare the packages. And so work evolves, and what that work is will continue to evolve.
Okay, thank you. Ethical question, so it's stressed. As robots become more sophisticated, the question of whether they should have any legal or ethical rights may arise. What is your opinion to that?
I don't have an opinion.
Maybe reply?
No, I think the question will arise. The question is there. It will have to be answered in some ways. I think we're probably going to look at specifics before. I don't see in the near future any regulation that says robots have rights like this and this and that. I don't think that's going to happen. But I do think at some point there's going to be a need to really address the question.
Okay. Hi, do you think that Boston Dynamics Atlas robot video with flip jump is real? There was rumors that it's fake.
No, it's true.
Reply. Hope it's enough.
It's true. There's actually in their facilities, there's a room, I think bigger than this, that is basically walled off, where they just test use cases like this. There's also, if you look at the videos, you have also the videos about the fails of those robots, which are sometimes hilarious. Sometimes not, because every time they fall, it's a lot of money that falls.
Okay, how much does human shape limit the design of robots? Would not be high advantage for robots to have, for example, legs like insects in going upstairs?
Yeah. The way we think about it is that the robots need to be conceived for the jobs they need to do. And so having a full humanoid, shaped robot, as I said, is only useful if you think of it as a general purpose application. In any other way, you could have the face because it's a robot you want to interface, but you don't need legs, right? You could have wheels, or you could have, much more appropriate element integrated. It needs to be designed for, having a good return on investment. That's the bottom line.
Sure. What do you think of organic computation and materials that were? Any chance it's becoming relevant for in the upcoming decade?
Sorry. Organic computation materials. Well, it's part of the future, and those things contribute to that future. I cannot predict honestly what will be in the next generation of robots that you're going to see 10 years from now. First of all, things are moving too fast to be able to predict them. You have people everywhere working on these things, so I'm sure it will happen. They will have a role. Maybe they will disappear 2 years later. I have no idea.
Okay. I think it will be the last question. Let's say it's year 2000. We have superficial AI and general purpose robots that are self-conscious. Do you think of dystopia in the future we will be slaves of robots? Or do you believe that we will live somehow in harmony? I'm robot. I'm legend.
Yeah, so, it's interesting because if we were right now in Tokyo, I think the answer that you would expect was, yeah, we'll be fine. And we're in Europe, and the answer you're expecting is, oh, there's going to be a clash sometime. So it's very difficult to say. Now, we think that AI, and what we were discussing last night with AJ, the bald guy over there, and we actually think that robots will end up in AI will actually end up taking the jobs of highly skilled people before they do take over lower skilled labor, and we might find ourselves in a position where, people still need to pave the roads. People still need to build houses. And sometimes it's very complicated, right? Go renovate an old house. Having a robot do that will be hugely difficult, but humans do it on a daily basis. But at the same time, what are the jobs that are easiest to automate? You've heard about Gen AI. Lawyers, CEOs, those are jobs at risk, right? But laying bricks, we need that. So we might actually end up with a future that we did not expect at all.
Okay.
Yeah, I know.
Okay, I want to ask, I heard that people have fear from human-looking robots because they look like sick, strange, unusual people, and from evolution, etc. We have initiative to avoid it. Do you think about this? I tried to save the situation, so we should say that robots are not okay.
We have to say that?
No. We should say the truth and only truth.
Yes.
So robots look sick, and that's why, from evolution point of view, we omit them. What do you think about this?
I don't know. Have you seen a mecha? Which I don't have a picture right here, but look up Ameca, Ameca. She really just looks like a human, and this is, they do look strange sometimes, but I mean, come on, we got used to microwave ovens, right? I mean, talk about an ugly face.
Okay. Thank you for answering the questions.
You're welcome. Thank you, guys.